Fantastic, the print is done, except looking up at the build plate, it failed. Only one of my 2 gear prints was successful. Let's have a look at why the one failed. So looking at the design again, I suspect that the problem might be the ratio of the surface area between the first layer that we put down on the build plate and where we get to the middle of the gear, which you can see is basically a solid disc. I think we're just asking too much of the first layer in terms of adhesion to then be able to support pulling that entire disc off the FEP. So let's see if we can fix this through a better design. The first thing I want to try and do is actually just hollow out the web, and let's do that by first sketching out the cutout that we'd like to have, and here I've already done that, just a little very simple cutout, and then we need to extrude that to make the cutout. We can then add some webs, and that's actually very easy to do in Fusion 360. You simply draw some lines where you want the webs to be, and you create them. You just say create webs, and it does it pretty automatically. The next thing to do is to create some fillets so we don't have sharp transitions. Fillets are really your friend for SLA printing because they ease the transition between layers and allow you to build it up. It's akin to kind of tilting the part and putting it at 45 degrees or 30 degrees if you've got appropriate fillets. Another way to think of it is draft on a casting. It allows, a gradual build up of the layers. We can then pattern the cutouts and then finally finish with the rest of the fillets. If we now look at the cross-sectional area, you'll see it is much smaller than the original. And I'll actually show you in a moment some numbers of the difference between the 2 surface areas. That looks like a successful print. Let's get it off the build plate. So here we have our completed 3D prints of these helical gears. Here's the first one, which failed. You saw the failure on the print bed earlier. Here's the revised design, which has a much lower cross-sectional area, which is actually printed beautifully. And the 2 pinions that, basically it's the same design for the 2. Just to give you a little bit of some of the detail, you can see how that looks. There we go. I must say, every time I print with the Anycubic Photon Mono, I am astounded by the detail that it provides. Okay, so now let's check the dimensional accuracy. This is supposed to have an 8mm bore to fit on a stepper motor. Let's see where we get to, just over 8. That should be about 7.5. That looks good. That one's just around 8. And let's check how it fits onto a stepper motor. So, stepper motor, D shaft. It's a little bit tight, but I guess that's what we want. That's a beautiful fit with the D shaft straight off the printer. This is supposed to have a dimension of a 12mm fit for a shaft. I made the hole just over 12mm, I think 12.05 or 12.1 in Fusion. And let's see how it does. Oh, that's a beautiful fit. Absolutely perfect mesh. So, don't design your parts like this with lots of surface area. Reduce the surface area and you'll get great prints.